Algebra students, in today's mini lesson, we are going to be going to the neighborhood of make-believe. Thus, you see Mr. Rogers over here smiling at us. We'll have to do that because we're going to be asked to solve a quadratic equation like the one you see right here. X squared is equal to -1. Well, I know that we're supposed to take the square root of both sides in order to solve this. So if I were to take the square root of x squared and then the square root of -1, I would end up with x equals plus or minus. Now I have to wait a minute because the square root of -1 doesn't exist. Now you were probably taught a long time ago that the square roots of negative numbers never exist, because there's never a number that I can square that will then become negative. If I have +1 times 1, that's going to equal +1. And if I have -1 times -1, that's also going to equal +1. There's no way to square a number and make it negative. This doesn't work, and that's what you were always told. No good. Well, mathematicians weren't happy with that idea. They wanted to be able to solve equations that had negative roots. So what they did is they came up with an imaginary number. So the answer to this equation is actually plus or minus I. I is the imaginary unit, okay? And I, by definition, is equal to the square root of -1, a value for which there had previously been no particular answer. So having this I, the imaginary unit, the imaginary number, allows us to then solve quadratic equations that normally we wouldn't have been able to do. For instance, if I had the equation here on the left, x squared is equal to -28. Well, once again, I try to get the square by itself, which in this case it is. Once the square is by itself, I go ahead and take the square root of both sides. Now here's where I run into trouble once again. The square root of a negative number isn't supposed to exist, but I'm going to treat this as a product of three things as I simplify this expression. First of all, the fact that it's negative tells me that I'm going to factor out the square root of -1. That takes care of the negative symbol. Now I also look at 28 and I know that 4, a perfect square, is a factor of 28. 7 would be the matching factor, 4 times 7 being 28. Now as I write out these expressions, you remember that there's a plus or minus in front of all this. I'm then going to simplify. So the square root of -1, if you remember, that's I, the imaginary unit. The square root of 4, well, that's a perfect square. That's going to be 2. The square root of 7 just is what it is. I can't simplify it any further, so I'll write times the square root of 7. And then remembering that this is a quadratic equation that needs two answers and that square roots have both positive and negative roots, I'll put a plus or minus in front of my answer. So plus or minus 2i times the square root of 7 would be the answer to this quadratic equation. To think about it, if you had the exact same equation where it was x squared equals positive 28, as you solve this by using square roots, you would have x is equal to plus or minus. As I simplify the square root of 28, it turns into 2 times the square root of 7. So notice the only difference between these two answers is that this one has an I and this one doesn't. If it's the square root of a positive number, there's no need to put an I here. If it's the square root of a negative number, take care of that by putting an I in your answer. So with this next one, let's solve for x squared. So you can do this a couple different ways. I like to keep my variables positive as much as possible. So I'm going to add 9x squared to both sides. In the same level of operations, I will subtract 7 from both sides. I put a big equals bar underneath it. 3x squared plus 9x squared is 12x squared. 7 minus 7 is 0, so nothing to worry about here. Nothing to worry about here. Those two things cancel. And I have 4 minus 7. Well, that's -3. Next step in solving for x is to get the square by itself. Let's use division. We divide both sides by 12. And that gives us x squared is equal to -1/4. I'll slide this down a little bit. Now, if x squared equals -1/4, at this point, the square is by itself. We can take the square root of both sides. Again, a couple thoughts here. X is going to be equal to, square root needs a plus or minus. I've got the negative, so I know there's going to be an I in my answer somewhere. And then I think about the fact that this is, if I ignore the negative sign, which I took care of with the I could treat this as the square root of 1 over the square root of 4 using the quotient property. Well, the square root of 1 is 1, and the square root of 4 is 2. So what happens is I end up with 1/2 as a nice rational answer. I'll write that here in my answer, putting the rational part before the I. So if there was a radical part like there was here, we put it after I. So usually we go the real irrational number, then I, then the radical. So here it's the real irrational number, and then I with no radical required. Plus or minus 1/2 I is our answer. And that's just a little bit of work with solving some quadratic equations using the imaginary unit.